So sometimes using a visual representation can be helpful to determine which plant, or in which case flower shop, is the best. However, as we learned yesterday, it's important to consider the best scale to use on each graph so our data actually appears meaningful. So let's write a dependency statement. So remember, thinking back to the roses are red and the flower power, we were comparing the cost to the number of roses. So we're going to say that the cost depends on the number of roses ordered. So in this case, our dependent variable is the cost, and our independent variable is the number of roses ordered. So remember that when we're graphing, the independent variable is always going to go on the x-axis, and the dependent variable is going to go on the y-axis. So in this case, our y-axis would be cost, and our x-axis would be the number of roses ordered. So once we have our axes labeled, we need to determine our scale. So the scale involves choosing which data points to put on our axis and what to jump by. We can determine the scale by looking at the table of values. So in this case, we have our numbers of order. That's going to go on the x-axis. So look at both tables, and they're going up by 12s for a little bit, and then we start mixing some numbers in. So a good number to go up by, though, would be 12s or 8s or 4s, because most of them are multiples of those numbers. So since we have a lot of space down here on our x-axis, I'm going to choose to go by 4s because those numbers were divisible by 4. So each line is going to get a number: 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 52. Now, you're going to do this on each graph. You're going to label the numbers. If you want to, you can also skip every other number if it gets a little too jammed on the bottom here. And since our highest number is 43, I'm going to stop at 48 for both axes. Then I look at my money, and my money in the 1 goes from the highest number of 29, or the smallest number of 29, to 47. And in this table, we're going from 66 to 81. If I want to make sure that my table is equally comparing the prices, I need to use this same scale for both graphs. So a good number to go by on the y-axis might be tens. So remember that our corner is 0, 0, so I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to do that on both graphs so that I have my points labeled. So then we're going to label our axes. So remember, on the x-axis, we have the number of roses ordered. And on the y-axis, we're going to have our total cost. So then I'm going to use my data points from up here to plot my points. So one point that I have is 12.29. So I'm going to go to 12 roses and $29 and place a dot. Then the next point I have in my first table is 24 roses for $38. Then I have 36 roses for $47. Then I have 32 roses for $44. And I have 23 roses for $37.25. So remember that we're not going to connect our points because we can't have partial roses, so we're just going to leave our data points, and we need to label this. So our first place was called Roses Are Red. Then our second place was called Flower Power. So we're going to give that title of the graph flower power, and we're going to plot our points. So our first point is 1266, and then we have 2472. We have 3678, 3276, and we have 43 roses for $81.50. The same thing is going to happen in this graph. I'm not going to connect my points because I can't order partial roses. So if we look at both graphs, notice that the plotted points were going up as the line, so we were increasing or rising from left to right. So the shapes of both graphs show a steady increase in cost of roses as the number of roses increases. So if we go back and look at our graph, this means that as we order more roses, our cost was also going up, which would make sense. So the roses are red line. If we're thinking about where the roses of red line starts, it's going to be lower than our other line. So it starts lower, but it's a bit steeper compared with the flower power graph. This shape means that the service charge for roses of red is lower, but the charge per rose is higher because the line is going up faster. So let's look at some more things about the graphs. So this graph is shown again with the line just so we can see a couple more things that are noticed. So notice that we have numbers ordered on the x's, we have costs in dollars on the y's. So if we notice looking at where they intersect on the y-axis. So if I look at the y-axis, remember the y-axis is our vertical axis. So this is our y-axis on both graphs. So the roses are red line, which is the one that's on the left. If I look at where it is intersecting on the y-axis, it's at $20. That's the point 0.20. Flower power, on the other hand, is higher up at 0.60. So the reason that this is happening is, remember that this is our service charge for each company. So let's try some of these Agile Mind questions. So if the team orders 45 roses from Roses Are Red, how much will they pay? So if we look at Roses Are Red, and we're just going to estimate, so 45 roses gets us about here, which is about $52 or $53. So we're going to say about $52. If they order 45 roses from Flower Power, 45 roses from Flower Power is going to get us a little bit higher. We're going to say that's about $82. Remember, we're just estimating because it's hard to see the exact point from the graph. How many roses would you get from each place for $70? So for Roses Are Red for $70, we are intersecting with our line at this point. So we're going to say we're going to get about 67 or 68 roses. For Flower Power, if we spend $70, we're getting much less roses. We're only getting about 20 roses, which should make sense. It has a higher service charge, so we can't get as many roses until we start ordering more to save more money.